So, so you're talking quite a bit about kind of the mysteries of the universe and how astronomy and astrophysics are really part of this greater quest to explore things that we don't know that much about when we compare our knowledge of life and think how things go on Earth. I know you're a black hole guy. Do you have a favorite discovery or a favorite project that you've been able to work on, or even that you've had colleagues work on?
So yeah, the sort of things that I've done early in my career. I was involved with a research group that was doing kind of the first pioneering work on the topics of observation. We call them blazars. They are a subclass of these so-called active galactic nuclei. And so with colleagues, my team was among the first to understand what was the sort of galaxy that surrounded the supermassive black hole in this subclass of active galactic nuclei called blazars. I joke that it was probably a mistake to choose blazars. Blazars hadn't been well studied, and there was a reason for that. Well, there's a fundamental reason for it, is that they're relatively rare.
Yeah.
But the more important reason is that they are so difficult to observe, for reasons that I'll mention shortly, that, you know, it was only the young scientist, me, who thought, well, that would be an interesting thing to study, so let's do that. The issue with blazars, so active galactic nuclei are these things, they are feeding supermassive black holes that are in the middle of galaxies. And when the supermassive black hole feeds, or, you know, absorbs, accretes gas and stars and that sort of thing, they launch a jet of material, of relativistic particles that get spurted out of the region near the supermassive black hole. And these jets, you know, we can observe these objects with the jet at various angles on the sky. And objects that I'm sure you're aware of, and our viewers and listeners are aware of, called radio galaxies, are those nice big elliptical galaxies that have those beautiful radio jets that flow off of them. And there's usually two. There are always two. We can usually see the two in the radio galaxies. So we see those nice jets in the radio galaxies because the jets, we're seeing the jets edge on, as it were, right? We're looking kind of at the supermassive black hole edge on, and we see the jets coming from above and below. And other sorts of active galactic nuclei, that the current thinking is that the different subclasses of active galactic nuclei are caused by the different orientation of the jet angle to our line of sight. So radio galaxies are one that we see edge on. The blazars are the other extreme, where we're basically looking at the jet face on.
Down the barrel of the jet, so to speak.
Down the barrel of the jet. And so this makes them very important because we can see all the way, potentially, all the way into where they're launched near the black hole. But there's a lot of energy being produced around the black hole and in the jet. And so it's like looking down a flashlight. And so they're exceedingly difficult to study. And the work that I did looking at the galaxy that surrounds that supermassive black hole, that was very, very difficult work because, again, you know, you're looking at a very bright flashlight, and it's hard to see the region around surrounding
the components of the flashlight while staring into its beam.
That's correct. Yes.
Yeah.
Yes. So.
Yeah. No. Go ahead. Go ahead.
Well, so just fundamentally, we needed very high resolution instrumentation. So I used the Hubble Space Telescope. That was one of the first instruments that gave us the resolution that we needed. And there have been since other instruments that have allowed us to study these objects. But they're neat. And so what was neat about it for me was that it was kind of groundbreaking work. Definitely. But really difficult. And yeah, probably if I go back in my time machine, I probably wouldn't do it again.
But that's the beauty of it. Right place, right time, right naivete. Perfect. Now, how do objects like that compare to something like a quasar?
So a quasar is another type of active galaxy.
Yeah.
They're all the same sorts of things. And again, if this model is correct, it's just the orientation angle of the jet. So quasars are kind of intermediate between the blazars and the radio galaxies. Their jet is a little bit further off of our line of sight, 20, 30, 40 degrees from, you know, from directly looking at the jet or directly looking at it edge on.
Definitely. Now, you mentioned making those observations with Hubble, and it's no secret that NASA and everyone is making a big to-do about James Webb Space Telescope, and that being kind of the next big space telescope that will hopefully kind of take on Hubble's role and take it to the next level. As an astrophysicist, what would you be able to see, and what more would you be able to get out of a telescope like that?
Well, so Webb is a big telescope, right? Much bigger than Hubble,
Mhm.
and so, you know, what that gives us is sensitivity,
Yeah.
right? The bigger the mirror on a telescope, infrared or a visible light telescope like Webb or Hubble, or our ground-based telescopes, the bigger the mirror, the more photons you collect, and so the more photons you collect, the fainter the objects you can see. Uh, bigger bigger diameter mirror also means you have higher resolution, so you can see higher resolution objects. Webb is observing in the red and infrared parts, part of the infrared, part of the electromagnetic spectrum. So that allows us to see other physical processes that are taking place astrophysically.
Mhm.
And also it allows us to go further to larger distances, because the further an astronomical object is, the more its light is redshifted, as we say. And so if important regions that are emitting electromagnetic radiation are redshifted because they're distant, they're redshifted into the infrared parts of the spectrum, then Webb can pick those up. And so we'll just be able to go a little bit further into the distant past with more distant objects and see different sorts of emission mechanism from the astrophysical object itself, plus having that better sensitivity and a little bit better resolution.
Definitely. In a way, these space telescopes really allow us to travel through time.
Yes.
Yeah, which is, you know, people talk about, oh, one day we'll invent time travel. And it's like, well, with things like Hubble or with Webb, you know, scientists can literally look back in time in real time from our perspective,
Yes.
which is, you know, science is very often much cooler than science fiction in those kinds of ways, which obviously I love.
Absolutely, and so do I. And to your point, you know, all astronomical objects are observed as they were in the past,
Yeah.
right? Because of the finite travel time of the speed of light. And so that includes the moon, which is relatively nearby, you know, a couple of light seconds, and the sun, a couple of rather 8 light minutes. But then everything else is much further. So we are observing them not as they are today, even though the light is arriving at us today, but we're observing that object as it was in the past. And so it's all astronomy as a time machine.
Absolutely. Even walking into your backyard and just looking up at the stars, you could be looking at something from millions and millions of years into the past, which I think we often take for granted because we have this incredible vantage point, but it really is incredible not just that we have that opportunity, but that we know enough about it to recognize that that's what's happening, which is, I think, pretty special as a
Yes,
species that we've managed to make that happen.
yes, indeed. It's quite remarkable, isn't it?
Now, talking about kind of looking out into the solar system, I want to talk a little bit about traveling out past the solar system through the cosmos. You know, everyone is very much on the let's travel to Mars, let's get back to the moon train, but there is still an ongoing conversation of what if we traveled far, far beyond our little solar system, our little neighborhood? Is something like interstellar space travel possible? Is human crude interstellar space travel possible? I mean, I know we have technologies like, um, you know, light sail technology, solar sail technology. Is that something that we know is in the realm of possibility yet? Or is it still something that could be possible if that technology presented itself?
So it's certainly not possible today from a technical perspective. And so then the question is, will we ever technologically get to that point? And so that's a slightly different and harder question. And this is pure speculation on my part. I don't have a crystal ball or any particularly special insight into the technology. I would be surprised if we're never able to do that from a technological perspective. But there are issues, and I mean, the main problem is that the distances are so immense.
Yes.
Right. So, barring the discovery, the development of some sort of Star Trekian type propulsion
Jumping
system,
through
right?
wormholes, or
Yeah, or warp
smash
engines,
the warp drive. Yeah, yeah.
the travel time is immense. So just to put this into perspective, and in a relative sense, so I'm going to go through a scaling discussion. So let's take the sun and shrink it down to a meter in diameter. Okay, and so that's the sun is big, and it's so big that it's mind-bogglingly big for humans. Humans can't deal with these big numbers very well. But let's shrink it down to something that we can deal with. It's a meter in diameter, and on that scale, the Earth is a centimeter in diameter. Okay, so that gives you kind of the scaling of the diameter of the size. So that 1 centimeter Earth compared to the 1 meter sun, the distance between the Earth and the sun on that scale is just over 200 meters. So, size of a football field, right? On one end, you have a 1 meter sun, and on the other, you have a 1 centimeter Earth.
And that's within the close confines of our neighborhood.
Yes.
Yeah.
The very close. Yeah, that's
very,
almost
very
within
close
our house, right?
Yeah, exactly.
In our side yard. Jupiter, by the way, is 5 times that distance. The nearest star is 35,000, 36,000 kilometers away. And, so the 1 little centimeter Earth and the 1 meter sun that are 200 meters apart, well, the nearest star is, 36,000 kilometers away. Yeah. These are rough numbers, by the way. I'm sure I'll get checked on
totally.
But just gives you the immense distances, yeah. And the nearest star is truly within our neighborhood.
Yeah, definitely.
So, and the nearest star is 4.2 light years away. And then everything else is much, much more distant than that. So the travel times, I think, are problematic. Mm-hmm. So how do you deal with that? And, maybe an individual human could probably make the trip to Proxima Centauri, the nearest star.
Maybe start to finish full lifetime kind of a time frame.
Yes. Mm-hmm. But so that's a problem, right? But the bigger problem is that space is a pretty violent place, and there's lots of radiation. And so, not to mention, lack of gravity, which is problematic for humans, for physiology as well. I'm most concerned about the radiation. So there are high energy
more immediate particles. Damage. Yeah.
Yes. And so how do you, and you need a lot of material to protect against that. You either need a lot of water, because water absorbs radiation quite well, gamma radiation.
Water that would somehow last or be able to be replenished over these immense timescales.
Yes, or it's very massive, right? So lead plating. Well, it's expensive to move
humans
mass.
In a lead can.
Yes.
For 100 years.
Yes, exactly. And so, will we overcome these things? I'm almost certain that we will. I'm an optimist, but even without that optimism, I think that we can overcome that. But those are big issues to overcome. The travel time and the harsh environment, and an environment that's harsh to biology. And so we need to figure out how to deal with that.
Definitely. I mean, even as agencies like NASA are planning crewed missions to Mars,
yes.
these are huge, seemingly almost, but not quite, almost insurmountable issues, radiation, timescale, having food that will not just last, but that won't nutritionally degrade over this time period. Any chance of return? Is it ethical to even send people out on a one-way mission? I mean, these are a lot of really big questions that we're trying to answer, even for seemingly short trips, compared to something like interstellar travel. So
Yeah, that's right. I mean, to your point, even going to Mars, right? That's, what, 6, 7, 8, 9 months, and a lot can happen in that time. And again, coronal mass ejections from the sun, high energy charged particles, just the cosmic rays that are coming in through the galaxy. That's very problematic, even on a relatively short journey like that. And then being on the surface of Mars, right? So Mars has less of an atmosphere and
much less.
much weaker magnetic field, and so the radiation environment there is not optimal.
Absolutely. And I know that there are, people speculate about if we ever had humans living on Mars, perhaps they'd live underground to kind of prevent some of that radiation exposure. But we're a long way away from having tunnels dug and bases built. And so there will at the very least be a pretty substantial adjustment period where either humans are going to endure that dangerous radiation exposure, or we'll have to figure out some kind of intermediary solution.
Yes, that's right. And there's talk now, because they've been discovered, these lava tubes
Yes.
On Mars. That's really quite intriguing.
Yeah.
I kind of that that has increased. I wouldn't mind going to Mars, but I think it would be kind of neat living in a lava tube as well. So maybe that's increased my desire to go.
I was actually the other month I was in a lava tube during a Mars analog simulated mission, in a spacesuit in a lava tube, thinking, would I really want to live in this lava tube? And I don't know, maybe it was really cool. So I'm with you, Joe. I think lava tubes might be something to explore, especially since to get to Mars, specifically NASA is looking at the moon as a jumping off point, and we already know that there are tunnel systems, similar-ish tunnel systems on the moon, that we might be able to test out some of those technologies and things in.
Yeah, wouldn't that be neat?
Right? Yeah.
Yep.
Start with a lunar lava tube, build a base camp there, move to Mars,
Yes, indeed.
So you would say yes? You'd sign up for that trip?
Maybe not the first one, but but yeah, it would be. I think it would be a neat thing to do.
Totally.
Mars has always fascinated me, and it's just intriguing, and it would be fantastic.
Definitely. So we're talking a little bit about Mars. Obviously, we would be life on Mars if we landed there, but next month NASA's Perseverance rover is landing, and one of its main mission objectives is to search for signs of life. That's signs of if there was ever life on Mars, if there could ever be conceivably life on Mars, what that might look like. I'm curious, when people think of life on Mars, especially because of how it's been portrayed, Martians, Ray Bradbury, all that good stuff for the last 50, 60, 70 years, I think people have a certain idea in their heads. But I think the microscopic reality is a little bit different. I'm curious, do you think there has ever been life on Mars, and what do you think that's looked like?
So I'm the non-expert here, and again,
Yeah.
this is
I'm just curious.
informed opinion. By the way, this is probably the most common question that I get when someone knows that discovers that I'm an astronomer.
Yep. They're like, where are the aliens? It's the first question every time.
Yes.
Yeah.
Yes, exactly. So I would, given what we know about life on Earth, in particular, the single-celled, biology, kind of everywhere we look, we see life. And more importantly, in the most extreme environments, we see bacteria and single-celled life, at deep sea vents with ultra high pressures and temperatures, in high temperature environments, in very high radiation environments, right? And so I think that's an indicator that life, at least at the single cell level, is probably pretty common.
Yeah.
And whether that single cell life exists on Mars today, I don't know. I wouldn't be surprised. I mean, it would be fantastic if we find that. I would not be surprised if that were the case. You know, there are environments that are similar to the extreme environments on Earth. Of course, there's much more extreme environments, but I wouldn't be surprised if there are single cell life forms on Mars today. I would be really surprised if they didn't exist in the past at some
Really?
point.
Yeah. Especially, you know, if we look far into the past when Mars had a much more substantial atmosphere and was fairly Earth-like compared to what it is today.
Yes, yes. And, you know, here's the intriguing thing. So there's lots of Earth material on Mars, and there's lots of Mars material on Earth from meteorites, right? And so, you know, is life on Earth, did life on Earth start on Mars? And if there's life on Mars, or there was that actually, you know, Earth organisms that were transported through meteor impacts and that sort of thing? And, you know, that certainly could be the case both ways.
Yeah. I mean, how amazing would it be if life in our solar system originated on Mars, hitched a ride on a meteorite, and proliferated here on Earth through sheer science and circumstance, really?
Mm-hmm. Yes,
Yeah.
indeed. Now, you know, we could take that to the extreme and say that life on Mars, if it exists or existed, certainly life on Earth might have come from outside of the solar system, right?
I think so. Possibly.
I think so. Yeah, it's the, you know, that's the panspermia hypothesis. But we're finding all sorts of prebiotic precursors out in the gas clouds that form stars, and in the gas clouds around newly formed stars that are currently forming planets. You know, hydrocarbons and amino acids and these sorts of things. And we don't know how life began yet. I mean, that's obviously an active area of research, but, you know, I don't think it's a stretch to say that that's a possibility, that life was brought in to the newly forming solar system and seeded certainly the Earth and probably other places as well.
Yeah. So we can count that as within the realm of possibility.
I would think so. Yeah.
Definitely. So, you know, kind of on the topic of aliens, without jumping into the complete conspiracy, which I'm sure you get those emails too. Um, uh, you know, a few years ago, the first ever interstellar object to be observed and recorded in our solar system, called Oumuamua, was spotted. And, you know, at first, everyone was very quick to say, what if this is an alien visitor? What if there is microscopic life on it, et cetera, et cetera? It was studied fairly intensely while we had a good handle on it, but there are still and continue to be resurfacing theories that potentially it has some kind of extraterrestrial connection. Now, I know that everyone has a different opinion on it, and I'm curious what you think of this strange cigar-shaped space rock.
Yeah, and the, you know, the speculation is that in fact it's not a space rock, right? So
Exactly, yeah.
it's certainly extrasolar, and the salient points about this are that it truly is extrasolar, and we know that both based on the trajectory and then also the velocity that it's moving. It's not in a bound orbit around the sun.
Mm-hmm.
Now, you know, there are objects in our solar system that can get gravitational kicks and they leave the solar system, but this is clearly an object that has come from outside of the solar system. And almost certainly there are many others of these sorts, but as you correctly said, this is the first one that we were able to observe definitively, right?
Especially because, you know, objects like this, at least what we've seen with Oumuamua, seem to kind of pop in and then kind of go through our solar system, you know, just a brief visit. So, you know, who's to say what other objects may have just made their way through, and we may not have had the technology at the time or not been looking in the right place. But yeah, this is just the first one that we've seen.
Yes, exactly. And so let me, first of all, there's a lot of debris around stars.
Yeah,
Uh,
lots,
Planets, right?
lots of
Planets are
stuff.
debris, right?
Yeah,
And
or just debris that rolled up into a nice little compact, dense thing.
yep, exactly. And ranging from that to grains of sand and asteroids and comets and that sort of thing. And so there's lots and lots of stuff. In addition to the gas and dust clouds that are just there that haven't yet formed stars. So there's a lot of
Can I
stuff.
quote you on saying, so Joe, what's in space? Joe, lots and lots of stuff. Yeah.
Yes, absolutely. So, and when you look at our solar system, right, our immediate neighborhood, we understand really well, and we're understanding more and more about the solar system, but there's a huge volume of material way out in the distant reaches of the solar system. And it's all gravitationally bound to the sun, but very weakly because it's so far away. So, all it takes is a big planet like Jupiter or Saturn churning up the inner part of the solar system to fling stuff out, interactions with other passing stars over the lifetime of the solar system that pulls stuff
Light
out.
tug, can just kind of break that tenuous grasp that our sun has on these little pieces.
Yes, exactly. And in a newly forming solar system, stellar system, where there's a lot of debris in the protoplanetary disk, the disk that's forming planets rather. There's collisions and all sorts of things. We believe that our moon was caused by a collision of a Mars-sized body with the early Earth. And so you have these collisions that throw stuff out into interstellar space. So that's not unexpected, and which is probably why Oumuamua is almost certainly a piece of debris of this sort, right? Not a spacecraft. Now, the intriguing thing is that if we started this discussion by talking about interstellar travel, right? And we don't yet have the technology, but we will soon have the technology to be able to send a very small probe to the nearest star system. And we're not
slow but directed journey.
Yeah, exactly. Yes, exactly. But what we would do, at least what's being discussed because it's the easiest so far, is we would send a probe on a high-speed flyby.
Yeah.
We're not talking about flying into the Alpha Centauri system and then finding a planet and going into orbit. It's like just zipping by.
Orbit, landing, sending a photo.
Yeah.
Not there yet. Yeah.
So what's being proposed is a small spacecraft that's zipping by at ultra high speed and snaps a couple of photographs and beams them back to Earth, and then it's gone, right?
Yeah.
So this is, Oumuamua came through the solar system in a very high velocity, and it's not a small metallic probe, but who knows? And so that was the intrigue of this. That it came from outside of the solar system. It could be a probe that did a high-speed flyby.
That kind of thought, like, hey, this looks like what we want to send somewhere else. Is there anything to that? That
Yes.
kind of thought, yeah.
Yes. Now, we have to apply Occam's razor. So Occam was a great 14th century philosopher from Britain, and he basically gave us this philosophy that says you have these multiple explanations. In the absence of anything else that can allow you to distinguish between them, you must choose the more simple of the explanation. That is the one that has the fewest assumptions.
And this is not the most simple of explanations.
That's right. That's right. So I would love for Oumuamua to have been or to be an alien spacecraft. That would be fantastic. It probably isn't. Even if it is, we wouldn't be able to determine that at this point because we can no longer, it's zipped by and it's too far away for us to study. So we can speculate, and it's worth speculating, but I think with Oumuamua at least, we won't have a definitive answer.
I think that's one of the great fallacies of science and of people especially who study space. Often I get messages like, oh, they know something that we don't know and they just don't want to tell us. Meanwhile, scientists are excited about new discovery. If if we had information that it was some passing alien signal or ship, that would be an unbelievable discovery. You could not keep people from telling that. You couldn't keep that secret.
Yes, that's right. That's right. Exactly.
Oh my gosh. I actually have a couple of really fun questions that people asked on the forums that I want to just kind of throw your way.
Sure, sure.
There's a lot of talks, on the forums about Mars with the upcoming mission, and there were a couple questions about disease and contagions. I know you're not a planetary protection person specifically, but with any mission, whether to the moon or to Mars, there is the concern that either we might bring something there that we shouldn't, or we might bring something home. Like we saw with Apollo 11, the first humans to land on the moon, after getting home to Earth, they had them quarantined for weeks because they thought, are they bringing home moon bugs? It sounds funny looking back now, but at the time, we just didn't know. And so I'm curious what the conversation is surrounding moon bugs when it comes to going to and returning from Mars.
So the return is a little bit more difficult because, I suppose, I don't know what the protocols are for astronauts, but presumably there'd be some sort of quarantine for that.
Yeah. There is always a pre-flight quarantine, even if they're just going to the space station, because we don't want to bring germs to Mars, but we also don't want to bring germs to an enclosed space station with other people living there.
Yes, exactly. And humans are biologically more difficult from that perspective, and so yes,
we are
indeed.
A challenging species.
Yes. The material going to Mars and other places in the solar system are usually, not usually, I think it's almost always, especially if there's the target is a potentially biologically significant location. So like Mars, right? So the material going to Mars has been thoughtfully decontaminated. Yes. Because obviously you don't want to contaminate a pristine environment,
especially where you're looking for microscopic organisms.
That's right. So how would you be able to, you find something and
it's the bacteria you brought.
Exactly. So not only the desire to not contaminate the pristine environment or a unique environment, but also again to make it easier for us to determine whether any detected life is from that environment or brought by us. So a lot of work is done on decontamination. Coming back is more problematic, right? So like a sample return from Mars. Well, maybe it's contaminated, right? And so what do you do? There are protocols for retrieving material and then bringing them into quarantine and making sure that there's no, biological activity on the surface or whatever. So lots of
open up that canister to prevent any kind of cross-contamination.
Yes, that's right. That's right. So that's done actively. Can we say that it's I guess in the Mars situation, we can't say definitively whether it's been successful or not, but I suspect it would. It is, right?
Yeah. Perseverance will be caching samples for the first time to be returned, but we haven't returned any or even collected any yet. So theoretically, it should be sound, but it just hasn't been done or proven yet.
Well, it's not been done from Mars, but it's been done from asteroids.
Yes,
right?
Definitely. Amazingly. And Hayabusa 2 really paved the way, but OSIRIS-REx, it's really, to have a probe not just rendezvous with an asteroid and study it, but to rendezvous with an asteroid, study it, collect a sample, and manage to fly by in a way to drop off that sample and have that sample still be viable for research is an unbelievable feat.
Yes.
Oh my God.
Yes, absolutely. And so that's a testament to, the classical mechanics and the classical dynamics that, you know, that they're the the people that develop orbits and trajectories. It's just amazing. And that's one of the neat things about Mars. So I'm looking forward to seeing the animations of the entry,
Yeah.
you know, that will be coming out of NASA. I love to see that. And again, it's just a testament to, you know, how great these people are who do this work. But then also, you know, again, I'm a scientist. I'm a physical scientist. It's how, you know, how the universe works, and the laws of physics work fantastically well, and we understand them very well, and we're understanding them better and better every day. But you know, the gravity is a neat thing, and being able to understand it as well as we do is spectacular.
Yeah, it's amazing to see the laws of physics so profoundly proven and demonstrated with these elaborate, you know, rendezvous and mechanisms and landing patterns. It's really cool. And I'm
Mhm.
sure as a physical scientist, it must be especially interesting and fascinating.
Oh, indeed, and you know, uh, just what's involved in, you know, if you say, well, I'm gonna dump a probe on Mars, I don't care where it lands. Okay, I mean, that's a feat, right? You have to get there, and you have to survive and land. But to be able to say, well, you know, I put it down within, you know, 100 meters of or better of
Yeah,
where I was
this
expecting it to
exact
be.
site. And it landed gingerly and totally fine. And, you know,
Yes.
it's phenomenal.
Yeah, yes, I agree.
Yeah, I have one last Mars question
Okay.
for you before moving on, and this is also from the forums. People are curious. There was a recent study about it, about the wobble of Mars poles. So why are Mars poles wobbling? What might it be caused by? What's going on there?
So I will admit, because there's nothing wrong with not knowing everything, right?
Definitely not.
Um, I'll admit that I did not. I saw this question, and I didn't know about that until I saw the question. So I looked into it, and my first thought was precession. And you know, the precession of the Earth is the Earth's wobble on a large scale on its axis.
Yes.
And you know, the precession rate is 23,000 year cycle. And so I was thinking, well, that's, you know, why is that a mystery? We know what precession is, but this is something different. And so, you know, I think the answer is I don't know well myself, but I feel in good company, because it's not really well understood
Yeah.
where this wobble is coming from. And Earth's poles wobble as well, and these are small movements if I understand things correctly, on the couple hundred meters over, you know, a several year or even less time frame. So I suspect, and this is just again a
Conjecture
non-expert
is totally
here,
fine. That's fine. Yeah.
but you know, Earth and Mars, it's not, you know, we don't have a beautifully uniform density sphere that we live on, and Mars certainly isn't that way either. You know, there's chunks of mantle and core and that sort of thing um, in the Earth, and so I suspect that this non-uniformity of the interior of the Earth has some um, impact on the wobble. It may also be gravitational influence of all the different bodies in the solar system,
Mhm.
right? The sun and the moon in particular. With Mars, it would probably be the sun and you know, the Martian moons are probably too small to cause that sort of thing. But you know, it's probably a confluence of multiple things that are doing this. Wind loading on the surface, you know, as winds blow across the large scale structure of the surface, certainly more so on Earth than on Mars, because there are winds on Mars, but the atmospheric density is low. Um, I think it's just a mixture of these things. I can't say definitively, and my quick research into this indicates that it's not really well understood
No,
by those who had heard about it before.
those who are actively studying it, it's still something that is a bit puzzling, but yeah, as you mentioned, there are some pieces that seem like they like an obvious influence, but has yet to be definitively proven and shown.
Yes, that is correct. Yes, but again, you know, as we started at the beginning of this discussion,
Who knows?
lots of unknowns, right?
Yeah. You mentioned wind on Mars, and I have to, it immediately jumped my brain into a conversation we had the other day about the film The Martian.
I love
Now,
it.
it's a really fun watch. The book it's one of my favorite sci-fi books I've ever read. But it's funny because there's so much, at least in my opinion, really great like science realism shown, but at the same time there's some things that are definitively sci-fi. And so the movie, for those of you who haven't seen it, if you're watching this, starts off with a windstorm, a dust storm on Mars's surface that's really crazy destructive, and it leaves Matt Damon, Mark Watney stranded there. Would a dust storm on Mars really do that? Is that the science fiction, or is that the science side of things?
So it's science. It's the science fiction. Is the short
Definitively
answer, right?
science fiction.
And there's nothing wrong. You know, science fiction is great, and so lots of great things about The Martian. I loved it as a movie. It was fantastic, well done across the board. But it is science fiction, right? And you know, we need to have a compelling story and something that's gripping. So nothing wrong with that. But that is one aspect of the movie where, you know, certainly lots of strong, powerful dust storms, wind storms on Mars. There's an atmosphere, certainly. There's lots of dust. And, you know, we see things like dust devils that would probably be the equivalent of tornadoes on Earth. We see those on Mars. But the atmosphere is very low density compared to Earth. Yeah. And it can lift up this very fine dust on the surface of Mars, but that's about all it can do. And so, yeah, that opening sequence of the massive
wouldn't be pulling you to your feet and dragging you around. And
that probably would not be the case. Now, it wouldn't be very pleasant. You'd be surrounded by, you know, dust and probably, well, I was going to say it was difficult to breathe. It's difficult to breathe.
Probably getting into the nooks and crannies of your spacesuit, which would probably just be a huge pain. And
yes, indeed. And by the way, you know, we see that with the dust storms that occur on Mars, covering landers and rovers, and you know, covering the solar panels that we can directly measure.
Yeah, that's how, I mean, opportunity, as we all saw after over, I think, 5,000 days, you know, past its 90-day estimated time, that's what took it out. It, you know, its solar arrays got covered in that dust, and if you're a solar powered little robot and you can't access the sun, that's kind of it.
Yes, it's a problem.
Yeah. So I happen to have insider information that there are other science fiction works that you are a fan of. I'm curious if you have any favorite sci-fi, if sci-fi has influenced you as a scientist or vice versa, if your love for science kind of got you into science fiction, and where you fit in the sci-fi fandom world.
So all of those things, right? I love it all. It's
no
hard.
Pressure,
yeah, exactly. This is probably the most difficult question that you've asked.
I threw you a curveball with that one. Yeah.
But so definitively, it's Star Trek, and probably the entire you know, realm of Star Trek. But for me, it's the original series. That's
really
what I started with. Yeah. And so I think I said earlier that, you know, I've been interested in astronomy from a very early age, probably 5 or 6 years old. I don't know whether it was Star Trek that started that, but it propelled the interest. And so I would say that I owe a lot to Star Trek because of that. It had a profound effect. And, you know, and again, all of them, but in particular, the original series, it was very fresh and you know, still very fresh today, many of the episodes, because it was more than just the, you know, zipping around the galaxy. There was lots of depth to it that
lasers and adventure and action. There was real heart.
Yes, exactly. And a lot of, you know, social issues that we're still dealing with today that were presented in Star Trek. And so that was great. But you know, all science fiction written and you know, elsewhere in different media probably one of my favorite classic sci-fi um, uh, uh, pieces is Forbidden Planet.
Oh, yeah.
A really
A
great.
really like beautifully done kind of like sci-fi staple.
Yes, yes,
Yeah.
indeed, indeed. So other than that, it's really difficult to pull out because it's all of it.
Yeah. I think that's true for a lot of sci-fi fans. Obviously, we all have our favorites. You know, I'm a next generation girl myself. Can't help it.
Yeah, nothing wrong with that.
Uh,
It's
but but it's hard to not love all of it,
yeah,
because you know, as science and sci-fi and space interested people, it, that's it. It's all about the exploration. You know,
yes,
throughout Star Trek, throughout other sci-fi franchises and movies, that's what it all really boils down to. You know, it's just the need and desire to explore, and I think that's a really fundamental part of being a human.
yes.
Yeah. And do you agree with that? No pressure.
Absolutely. Yeah, 100%. Yes.
Yeah.
And like you say, that is, that need to understand and explore and it's all part of it. And of course, science fiction allows us to do that
Yeah.
in a inexpensive way.
Like
we're
a
not having.
safe environment, you
Yes.
can anything is where anything is possible.
Yes. Yes,
Yeah.
that's right.
Yeah, it's really interesting to look back on, you know, even as recent as Next Generation or back to the original series, and see the totally fake, crazy, futuristic technologies they were using, and today they're everyday technologies that we don't even think about. Smartphones, you know, iPads, things like that that were truly complete works of science fiction have now become a part of our everyday. And so it's interesting to see how you as a scientist have been influenced, and then how culture in general and even super obvious practical technologies right in our hands
Mhm.
seem to be very directly influenced by the world of fantasy and science fiction.
Yes, yes, indeed. And so, I think that's the thing about science fiction is that you might be viewing or reading something and they're talking about 100 years in the future, or even a shorter time frame. And what I find amazing is that even even the science fiction author usually isn't creative enough to make something that is truly uh, fantastical, because like you said, things that are discussed are created.
We draw from what's around us, even
Yes,
if we're making things up.
yes, exactly. But still, that's a fun thing to do, right? I mean, I think we're very creative. It's just that our creativity has limitations that we can try to go beyond. But it's also testament to the human ingenuity and human intelligence, is that we can do these things much in a way that is much more, how do I want to say this, that goes beyond what we can imagine, right? So we're sitting in the 60s and we're writing a science fiction piece and we're thinking, okay, this is 500 years in the future. Well, it crops up 10 years in the future, right?
Seriously.
And that's partly because of our ingenuity. But also, don't discount the fact that, like you said, researchers and engineers and scientists and others are inspired by, doesn't have to only be scientists, of course. They're inspired by this, and it causes people to think. And so there's an interplay between the science fiction and the reality. I think that is really quite fantastic.
Definitely. And it's interesting because obviously there are super direct inspirations, like with something like a smartphone or a tablet. But then there's things like, you know, food replicators, things that don't exist, but that have really made their way into the common consciousness, where now people are thinking about, could this be a thing? And eventually it might find its way into reality. In fact, there's the yearly tricorder contest where engineers kind of get together and try to replicate this Star Trek medical device that you just scan a person and it
Mm.
tells you what's wrong with them.
Mhm.
And it's yeah, it's just interesting to look back in history, but kind of see it unfolding today. Yeah, it's a lot of
Well,
fun.
the smartphone that you mentioned, think about, 15 years ago.
Yeah.
Let's go back 20 years, but even 15 years ago,
Mhm.
if you went back in time and said, hey, we're going to have this thing that does X, Y, and Z, people would
Yeah,
look like
sure.
you, like you had,
Sure.
exactly.
Yeah, I remember when the first person I knew had a smartphone, and I was like, "That's not going to catch on. It's too expensive. It doesn't really work right."
Yes.
And how wrong I was. How
No,
hilariously wrong.
I
Yeah.
was wrong in the same way. So we're in good company.
Oh my gosh. Well, we're kind of winding down time-wise. I feel like I could continue this conversation for the entire day, but I don't know if people would watch it for 24 hours. I don't know. If you're in the comments and watching this video in the future, let me know. But I want to kind of end on a more open-ended question.
Mhm.
Kind of where astronomy and astrophysics kind of sits today. I'm I'm curious what you think the greatest discovery of our time will be. Will it be what is dark matter? I know that's something that I think hangs over a lot of people interested in space and science, or something else entirely. I'm curious what you think the great white whale of astronomy and astrophysics remains.
So let me, and we've come full circle. In some senses, I you know I will let me answer this in two ways.
Sure.
Number one, I think that uh, that will be something that we don't know about today,
Yes.
right? So tomorrow or next year or 5 years from now, we're going to have this serendipitous observation, maybe with the web or some of the new instruments that we're bringing online soon. We're going to have new insight about things that we had no idea existed today. And like I said at the very beginning of this, that's the fun part of the field for me. But so I suspect it's going to be something like that. Now, of the things that are around today, dark matter is interesting. It's intriguing that we're not yet able to determine what dark matter is. So, for those of you out there that might not have heard the term dark matter or don't know what it is, basically it's the largest component of the matter in the universe is this material that we call dark because we can detect it gravitationally and its gravitational influences, but we don't know what it is. Almost certainly it's some sort of particle. Um, I'm holding the conservative traditional
You're in the
view of,
particle camp
yeah.
firmly.
And so, it could be something more bizarre, but I suspect it's going to be a particle. It's just that the particles that we think it might be we're not, the particles that we think it might be, we would think that we could start detecting them now, and we haven't yet. And so this is a problem, I think. But it's just our technology, I think, that's causing an issue. So that would be really nice to know. What is this stuff that makes up most of the matter in the universe? But I think more interesting is what is dark energy. So, if dark matter is what makes up most of the matter, dark energy is what makes up most of the matter energy budget of the universe. And,
And
this,
correct me if I'm wrong, but also what is kind of causing our universe to, the accelerating expansion of our universe.
yes, that's right. And so again, dark energy is this stuff, I guess we could say, it's the
So
property
this
of the
space
universe.
stuff, yeah.
Yes, that appears to have kind of popped into, well, I was going to say existence. It hasn't popped into existence, but it's become more important about 1 billion years ago. And it's caused, as you said, Chelsea, it causes the universe expansion to accelerate. And so, what is this? And this is an area of open investigation. And I think that would be, that's certainly the next Nobel Prize when we determine what dark energy is. That is going to be a Nobel Prize. And I think that's going to be the big issue of today. Of the stuff that we know today, what is dark energy?
Definitely. Well, I look forward to the continued exploration of these bizarre subjects, and also to continue finding new questions and new mysteries out in the universe.
Absolutely. Yes. I do too. So, and we can talk about them in the future.
I think we might have to.
That sounds great.
Well, it's been so wonderful. Thank you, Joe, for hanging out with me today. It's been an absolute pleasure.
I agree. It was very nice talking to you.